Okay, so the amine functional group happens when you've got a carbon attached to a nitrogen. The nitrogen has a lone pair and likes to make two other bonds. So those bonds could be to other carbon atoms or could be to other hydrogen atoms, essentially. It can be one or the other. And we did talk about classifying amides as primary, tertiary, and secondary, tertiary in the last chapter, and it's exactly the same thing for amines. We classify an amine as primary, secondary, tertiary based on how many carbon atoms it's attached to. So this nitrogen is attached to one carbon atom, so this would be a primary amine. This nitrogen is attached to two carbon atoms, so that's a secondary amine. And this nitrogen is attached to three carbons, so this is a tertiary amine. They're still all amines, even though some have hydrogens attached and some don't. Does that make sense? Very similar to what we did with amides. You guys following me here? Oh, did I put a primary here? Additionally, just so that you can see this, if I did this in line structure, it would look like that. This would look like this. The hydrogen would have to be shown because it's attached to nitrogen, which is a heteroatom. This one would be NH2 to the left. Condensed structure, you'd see this one as CH3, CH2, NH2, right here. This would be CH3, NH, CH3, and this one would be CH3, 3N. Everybody follow those line structures to the condensed structures to the Lewis dot structures there? Feel pretty good about those? Okay. Just one note when we're looking at saturation, because a nitrogen makes three bonds, it picks up an extra hydrogen. This formula has, say, C2H7N. Every nitrogen brings with it an extra hydrogen. So you could go from that formula to say C2H6 and see if this is saturated, what the saturation is for the formula once you remove the nitrogen, and one of the hydrogen atoms will tell you if that molecule is saturated or not. So for instance, if I had the formula C5H11N, how many units of unsaturation would you expect for that molecule to have? Karen says 1. Anybody else? Laura agrees. Becca agrees. So again, we remove the nitrogen and one of the hydrogens, C5H10. We plug that into our formula. If n equals 5, then 2n plus 2, that is 2 times 5 plus 2, should equal 12. Since I only have 10 instead of all 12, I'm missing 2 hydrogens. That is 1 unit of unsaturation. So then you could say, all right, what if I had, here's a particular example. There's C5H11N. I hope you guys can see 1, 2, 3, 4, 5 carbon atoms. There's one nitrogen. Let's confirm with 1 unit of unsaturation, which is a ring here. Do I have 11 hydrogens? That's 1. It's going to be 2 there. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sure enough, it works out. Excellent. All right, so your in-class activity sheet 15, number 1. How many amine isomers can you write that fit the following formulas? Draw them and label them as primary, secondary, or tertiary. Okay. So again, I've only picked a few here up to 4 carbons, so there's not going to be like a million formulas, but try to make sure that you cover all your bases. For instance, if I've got 2 carbon atoms and 1 nitrogen, My options are to put the 2 carbons in a row or 2 carbons on either side of the nitrogen. That's about it. That's, yeah, C2H7N. And then continue for the other ones. This one, would this be primary, secondary, or tertiary? What on the left? Primary. Perfect. And this one? Secondary. Perfect. Excellent. Any questions on all this? Amine structures? This is like the easiest thing that you've ever seen, huh? So easy. Okay. Now that you guys have done, maybe not the easiest thing, but maybe one of the easiest things in this class. Okay. All right, next, properties of amines. What we find with amines is that the NH bond is polar. So hang on, let's see here, properties. Oops. In fact, you have a hydrogen bond between the N and the H. And here you've got 2 hydrogen bonds between the N and the H. Because you have 4 hydrogen bonds and it's a little bit easier to network, we're going to find that, they get this lone pair up here, we find that amines have slightly higher solubility than alcohols of the same size. But because the NH bond is not as polar as the OH bond, it has slightly lower boiling points than alcohols. And it also depends whether you're talking about a primary amine, which has 2 NH bonds, a secondary amine, which then has 1 NH bond, and a tertiary amine, which has no hydrogen bonding at all. Okay. These 2 are going to be slightly lower in boiling point than alcohols because alcohol is a larger difference in electronegativity. It's more polar, essentially. Whereas these ones are going to be slightly lower than ethers because a tertiary is like a nitrogen analog to an ether. It would probably still be about 4-to-1, but in that case, Danielle, if you're talking about solubility of alcohols versus amines, it would likely be a question like, which of these is more soluble? And then you would say, oh, the amines are slightly more soluble for being the same size, that kind of a thing. But for relative boiling points, here we go. It's a chart from my lecture notes. I like these charts because you just see exactly what I'm talking about. I could talk about relative properties all day long, but when you see the relative properties, it's so easy to say, oh, I get it. Alcohol, higher than the primary amine. Primary amine has 2 NH bonds, so that's why it's higher than the secondary amine. All of those have hydrogen bonding, which is why they're all higher than the ether. And then the ether is higher than the tertiary amine because the oxygen is more electronegative than the nitrogen. For the same reason that the alcohol is higher than the primary amine. Everybody see that in the chart here? Relative boiling points. Good question. Where does the ketone go now? Oops, I don't know where my thing went. Lost all my windows. The ketones and the aldehydes are obviously lower than the alcohols, but higher than the ethers. But where are they versus amines? I'm not going to have you guys compare those. So amines, I might have you compare to ethers and alcohols. And alcohols, and ethers alone, I could have you compare to aldehydes and ketones. But I'm not going to ask you to compare alcohols and amines and aldehydes and ethers. That's too much. I have my limits, what I'm gonna expect you guys to do. So here's our examples here. You can see about what I would expect you to do. Rate the compounds by increasing boiling point. Again, what's the first thing you're going to want to do for these? Line, line, line. Yes, you guys are exactly right. So here's a line structure here. CH2, CH2. Line structure there. And okay, how would we rank those by boiling point? Excellent. John says the next thing is make sure we label these primary, secondary, tertiary, because the primaries have higher boiling points than the secondaries have higher boiling points than the tertiary. That's a good idea too. Excellent. Now tell me which one has the highest boiling point. The last one. Okay, so this is the highest, so we'll make it 4. And the next highest. Excellent. And then the next highest. Excellent. And then the lowest would be this one. Everybody agree with me? Lowest to the highest. Is that like the easiest thing that you've ever done in this class? Close to it. All right, next here, line structures at H2. I hope you guys follow me here and here and there. Which one's the lowest? Excellent. Yep, that last one is the lowest because it's just an alkane. And the next lowest? Excellent. It's a secondary amine. And then the next first. And then the alcohol is the highest. Okay, I will let you do the last one all by yourselves. I have confidence in your ability to do that. Okay. I hope that you also have confidence in your ability to do those. Okay. Next thing we need to talk about are, well, hang on a second. By following my, okay. By following my in-class activity sheets. Next thing we need to talk about is common nomenclature of amines. And amines, just like ethers and all the other ones that we've got, but we have the common nomenclature, and we also have our IUPAC nomenclature. Kind of annoying to have 2 different systems, but there's not very many common names, and at this point you're probably really used to seeing common names for all sorts of things. So none of these I think will be terribly surprising to you. But the common nomenclature is to say what's attached to the nitrogen and then name it as an amine. So in fact, in this respect, your common nomenclature is almost more common than your IUPAC nomenclature. So this is an ethyl group attached to an amine, so that would be ethylamine. And if I have, say, 2 methyl groups attached to an amine, what do you think we'd call that? Perfect. Dimethylamine. So note here, we're not doing like a longest carbon chain kind of a thing. We're just saying the parent is an amine and everything else is a substituent of it. So this is what's attached to it. And what might you call this thing? Perfect. I've got 3 isopropyl groups, so tri isopropyl amine. Excellent. And finally, you guys, I think, did memorize back in chapter 13 that if we have a nitrogen on a benzene ring, what was the common name for that? Excellent. Aniline. Perfect. Okay. Do you guys feel pretty good about those? No spaces when naming these. That's exactly right, Karen. Unlike common names for, say, ethers or alcohols where you've got a space, here we don't put a space. Good observation. We go back to our 15 one-day class activity sheet. Sections 3 and 4, name these using common nomenclature. So isobutylamine has a nitrogen, that's your amine, attached to a isobutyl group. I'm going to fill in my hydrogens. Guys feel pretty good about that? And if I did this one over here, I might say that's a cyclobutyl group. So this would be cyclobutyl amine. Is that fair? Okay, do you guys feel like you could do the rest of these, or do you want me to do 1 or 2 more for practice? Do the diisopropylamine? Okay. Well, nitrogen makes it an amine, and I have 2 isopropyl groups. So there's 1 isopropyl group, there's 2 isopropyl groups, and then I discover I'll need 1 more hydrogen to make that work. So there's diisopropylamine. Lisa already did the top left. Did you mean top right? Yes. Okay. What would this be? You guys tell me. Tripropylamine. Got 3 propyl groups on it. So tripropylamine. No big deal. You guys got this. Okay, let's try these ones. These ones all have aniline. So derivatives of aniline. So what would I call, how would I, let's see, aniline. Again, I always put the nitrogen there, and I never fill in the hydrogens until I know how many hydrogens are going to need to be there. So this is defined as the 1 position. So the 2 position, I've got a chlorine. The 4 position, I've got a chlorine. And that's everything, so I could go back and put in 2 bonds to hydrogen. You guys follow me there? Karen, no. Good question. As soon as we name it as an aniline, then the functional group that gives that its fancy name gets the 1 position. And Danielle, yes, if it has numbers, does not belong in the nitrogen. What if it doesn't have a number? What if it has an N? What does that mean? means it's on the N, right? It's exactly like when we were naming amides. So you guys are already familiar with this notation. When we named amides and there was something on the nitrogen and the amide, then you would just say it's on the N position. It's exactly the same. You guys already know this stuff. So here we go. If we made this N-ethyl 2,3-dimethyl-aniline, so here's your aniline. And then on the N position, I have an ethyl group. And then this is defined as the 1 position. So then at the 2 position, I have a methyl. At a 3 position, I have a methyl. And then once I filled it all by substituents, I could come back and say nitrogen needs 3 bonds. So I'm going to add in a hydrogen. Okay. Like up here, nitrogen only had 1 bond. That means I needed 2 more hydrogens to fill it out. This nitrogen has 2 bonds, so I need 1 more hydrogen to fill it out. Okay. Perfect. Yes, Karen, wherever you put that nitrogen, that's the number 1 position. Aniline is the one from chapter 13 that you memorized that is applicable to chapter 15. I mean, there are many other ones that you did memorize, and you should still have memorized, Danielle, right? Like benzaldehyde and benzoic acid and phenol kind of a thing. So let's do this one. Tell me what this one is, guys. Yeah, the only one in this chapter, Danielle. Okay, you guys are exactly right. There are 2 ethyl groups on the N. There's also a nitro group on the benzene ring. So this is a diethyl nitroaniline, but we have to specify where the stuff goes. So ethyl does come before nitro. So we're going to say N, comma, N, diethyl. And then the nitro group is at the 3 position or the meta position. Either is fine. Call it M nitro or 3 nitro. And then aniline is my parent. You guys want me to do any more from section 4? Do you feel pretty good about those? You guys tell me. Which ones do you want me to do? This one? Or you guys want, oh, John wants this one. Laura wants this one. It's okay. We could do all of them. It's good. Let's do this one. I want by let's, I mean you guys do this one, and I'll tell you whether you're right or wrong, because I'm pretty sure that you can do it. I don't want to sit here and do it for you if I know that you guys can do it. So do this one. I'm kind of disappointed that Captain Jack Sparrow isn't ending every sentence with matey. And the ethyl 3 nitroaniline, matey. Okay, so this is wait, which one were we doing? This one. So this is our aniline. And then lowest numbers if we go this way. So 3-chloro, 4-methyl, aniline. Yeah, there you go. Excellent. I know you did. I know you did. Okay, let's do this one. Tell me what that one is. N-ethyl, 4-isopropyl, 3-methyl aniline. Yep, it looks good to me. Oh, we haven't gotten there, Karen. It's an excellent question. We will get there. Because we've been doing common nomenclature, we've been doing simple amines, but once we get into IUPAC, we'll get a little bit more into there. But excellent. N-ethyl, 4-isopropyl, 3-methyl aniline. Okay. Excellent. Okay, I think you guys are good on this. Let's go back. Let's talk about IUPAC nomenclature. And by IUPAC nomenclature, I mean not actually IUPAC, but close to IUPAC. Let's look at what we've got, because as it turns out, some of this common nomenclature sneaks into our IUPAC, and we see both of them, particularly in mastered chemistry. So again, I'm going to have you guys look at these and have you guys tell me what the rules are. You guys know enough about the conventions of how these are put together. So what do you see? Okay. Your highest priority functional group, if it's an amine, it just ends in amine. That was easy. We still use that N substituent if it's off of the nitrogen. Good. We are generally looking for the longest carbon chain that contains our amine. Excellent. Good. Perfect. If I've got an alkene and an amine, we still stick both of those in the suffix. Excellent. Anything else? Should be a comma. This is the way that we're going to name our ether, right? So no surprises there, because ethers don't take any priority. What do you guys notice about this guy over here? Answers a question somebody asked just a minute ago. It's a mess. Aha, Karen sees it. This was named as an aldehyde. That must mean that aldehydes are higher priority than the amines. So how do we name an amine if it's not my parent? You stick the amino out in front, right? We did the same thing with alcohols, right? If the alcohol was the parent, it ended in -al. But if it wasn't the parent, we put a hydroxy prefix. So this is the same thing. If my amine is a parent, then it ends in amine. But if something else is a parent, then it becomes an amino prefix. So, and then after that, everything is exactly what you'd expect. Propanal has 1, 2, 3 carbons with an aldehyde. And then at the 3 position, I have a nitrogen because it's an amino group. And then I have 2 methyls, each of them on the end. So I know they go there. You guys following me there? Okay. The reason that I say this is kind of tricky, IUPAC would actually like us to look at this and call this a butanamine. Butanamine. That makes sense, right? Just like we did butanol and butanal and butanone. And it's consistent with what we do with the heptenamine, okay? However, this ill notation from the common nomenclature, has crept in to so much of the nomenclature of amines that it's almost just universally still used. So I think in mastering chemistry, when they're asking for IUPAC names, I'm pretty sure they're still going to have you use ill instead of an. Just a warning there for that. Okay, so that's why you see. But if you see butanamine or butylamine, you should be able to come up with the same thing either way. Okay. Amines have actually pretty low priority. They do have priority, but it's lower than pretty much almost everything else that we've talked about. Here's a list I compiled to your lecture notes, showing all of the functional groups that we have covered so far and their naming priority. Okay, so this is not the same thing as, say, like relative boiling points. Okay, this is a different list, sorted list. And this is by naming priority. So we know that alcohols are lower in priority than aldehydes, ketones, etc. So they get the hydroxy prefix. Amines are lower than everything else, so they would get the amino prefix. But if all you have is an amine and a couple of alkenes or alkynes, then your amine gets to be the highest priority. Now, I hesitate to give you this list because I'm only going to have you compare some few things, right? I'm never going to give you something with an aldehyde and a ketone because then you don't know which one to name as a substituent or how. So I could give you an alcohol with any of these higher priority groups or an amine with any of these higher priority groups. Or I could give you alcohol amines with any of these lower priority groups. You get the idea, but I'm not going to go crazy on you guys, okay? But hopefully this helps you kind of sort out what you're going to see. So you've got these. I'll give you like one or two, like one of these, then I can give you these as substituents because you know how to name those as substituents. But I'm not going to give you two or more of these if they're different things. Anyways, halogens, alkyl chains, no priority at all, even benzene rings. Okay, look at this chart for just a minute. And let's go to our in-class activity sheet. So next, naming stuff with IUPAC. Let's see how this is different, if it feels even different at all. So you notice propylamine. Again, true IUPAC would say that actually should be propanamine, butanamine, cyclopentanamine. But pretty sure Master Chemistry is going to want the YL because it's silly. Okay, so here we go. Propylamine, 1, 2, 3. This tells you the amine group is on the 1 position. And then 2 methyl groups on the nitrogen. So note that I waited to put hydrogen until I saw how many it needed, which in this case was none. Did you mean that chart, Danielle? I'm not going to test you on that chart. I'm just going to test you on naming things. If you can name it, then I know you know what's the important thing that you would need to get off the chart if you were following the chart, which you might not even. Oh, I'm not going to, I don't know. I might have both on the exam just to confuse you because I want you to be familiar with both. But it's not that confusing. I don't think you'll be confused. All right, let's look at this one. We've got my longest carbon chain that contains my nitrogen is this one here. So this is a cyclohexylamine or cyclohexanamine. That's my parent. But that automatically becomes the 1 position. And then I have an isopropyl group at the 4 position. I cannot call it para because it's not a benzene ring, right? And I have 2 methyls both on the N. So methyl comes before isopropyl, or sorry, isopropyl comes before methyl. So I've got 4 isopropyl, N, dimethyl cyclohexanamine. Yeah, pretty sure that Master Chemistry uses the YL. Not 100% sure, but pretty sure. Do you guys want me to do any of these other ones from section 5? No, Danielle. In that case, you'd say een or ein. Let's see, second one down on the left, John says N-cyclopropyl and ethylbutylamine. So but 1, 2, 3, 4 with the nitrogen attached. And then the N has a cyclopropyl group and the N has an ethyl group. These are pretty simple examples. I'm going to make us go to section 6 because wait, what did I do? There's a cyclopropyl on the group, right? And oh yeah, it should be an ethyl. You're right. There you go. Don't get so confident like me that you start to make silly mistakes. Yes. Okay. These ones have higher priority groups with the amine and have alkenes and alkynes. So this is going to answer the question that Danielle just asked. Let's do a few from this section. For this one, parent is a benzaldehyde. So that's why you can't forget all the stuff you've already memorized. There's your benzaldehyde. 2 position, there's an amino group. 3 position, there's a chloro group. That's everything. So I can go back in and add my hydrogens. Does that make sense? It's the order I do it in. Again, I don't add the hydrogen atoms to the nitrogen atom until I'm sure I know how many it needs to give it 3 bonds. Okay, help me out with this one. What's the longest carbon chain going to look like? Yep, an amino is an amine that is being named as a substituent instead of as a parent. And the names are so similar, it should be pretty easy for you guys to remember. Yep. So my parent here has how many carbons? And what functional group? 5 carbons. 1, 2, 3, 4, 5. Carboxylic acid. So that's the 1 position. 2, 3, 4 is pentene. So there's a double bond there. And then at the 3 position is where you had your amino group. Doesn't look like there's anything attached to it. So I'll give it 2 hydrogens. Excellent. Let's do this one. Almost perfect, Captain Jack Sparrow. Almost perfect. What you have is perfect. You're just missing one piece. Is it a methoxy group? Is it an ether? It's a methyl group attached to an ester. Karen has it almost exactly right. The only difference that I would say is, Karen, you need to not have a dash at the beginning. Having a space is what tells you that it's attached to the oxygen. Right, so good. This is an ester, 4 carbons, so that is a butanoate. my longest carbon chain with the carbonyl ester. And yes, I've got 2 methyl groups at the 3 position and amino group at the 4 position. So this is 4 amino. I'm obviously not going to need anywhere near that much space. I just wanted to make sure I had enough space. I gave myself way too much space. So 4-amino 3,3-dimethylbutanoate. And then to tell myself, okay, this is a methyl attached to the oxygen of the ester, I put the methyl out in front. So methyl space 4-amino 3,3-dimethyl butanoate. You guys remember each of those? Lots of little rules to follow. But that's how we name esters and carboxylate salts, both, right? We take the thing that's attached to the oxygen and we put it out in front with a space, and that's how I know what's attached to the oxygen, right? A methoxy would just have an ether. So, John, the 4-amino 3,3-dimethyl, we've got a methoxy, like a butanone would be a ketone, right? Indicating that you've got a carbon there. Careful. Careful, careful, careful. Yeah, I picked this one because naming esters can be hard. Let's do this one because this one has a methoxy and a ketone. So butanone has got 4, 1, 2, 3, 4. Ketone at the 2 position. Amino group at the 3 position. Methoxy group at the 4 position. So I'll have 2 hydrogens. So that's a butanone with a methoxy because they're not attached. Once they're attached, you have to name it like an ester. Okay, I don't want to do all of them because I want to give you guys a chance to work through a couple more. So I'll let you guys do these last 2 on your own.